Cheers, Trish. Today, my name is Aaron. I'm coming at you live from Singapore.
Good morning, good afternoon, and good evening to
Chips for everybody.
Chips for everybody. Yes, that would be an FYI.
we have Oleg and Mark. How's it going? Welcome to the stream and thanks for joining us.
I'm in San Francisco Bay Area. A little less snow than you guys see up.
How's it going, Tommy?
Hey guys, how are you?
Daniel, how's it going?
Hi, good, thanks.
Is Azure function is just an entry point to
Good morning, good afternoon, and good evening to everyone who's joining us, wherever you're joining us from. I am super excited for today's event, so thanks for tuning in. Today's event is going to be a fun, interactive event where we're going to be talking about the new Solace PubSub Messaging API for Go, and we're going to be doing some live coding. So the beauty of live coding in demos and while we're doing things live. So we'll see how things are gonna go out for today. So as people are tuning in, you're joining us whether from LinkedIn, YouTube, or Twitter. Thanks again for joining us. Please let me know where you are joining us from. I'd like to know whatever your which city, country, state you're joining us from. Put it in the chat window. I will be seeing the comments coming in. So that will be great. Just a quick reminder that all these events that we are hosting, this is going to be recorded on YouTube. You can find it in the Developer Virtual Events playlist on the Solace channel. And any future events that are coming up, you can see them on solace.community. So as you can see here, oh wait, this one, my screen is mirrored. So Gopher is going to be the highlight for today's event. Again, if you have any further questions, a quick reminder to anyone on the channel that this is a live interactive event. So if you have any questions, feel free to put them on the stream. And again, let us know where you're joining us from. I am currently joining you from Vancouver, Canada. It's raining today, shocker. But that's the classic Vancouver weather. So without further ado, I will be introducing Murat, who is a product manager at Solace. We'll be talking about the Go API. And then later, I'll be introducing Michael, and we'll be doing some live coding. And if you have any input from the audience for the live coding session, please let us know. So without further ado, I will bring in Murat. All right, Murat, how's it going? How are you?
Hello. I'm well. How are you, Tamimi?
Doing well. Things are well. How are things from your end?
Can't complain. Today is actually a rare thing where we have really good weather here in Ottawa.
Where are you joining us from? Where are you located?
So I am joining us from Ottawa.
Okay.
Eventually, I'll be at the Canada headquarters, but
Nice.
Right now it's still work from home. So from the comfort of my home.
Okay, that's fantastic. And what do you do at Solace, Murat?
So I'm one of the product managers for the core PLM team at Solace. More specifically, I handle the APIs and integrations for the core products.
Perfect. Fantastic. And so you said you handle the APIs and integrations for the core products. Today, we're going to be talking about particularly the Go API. So can you tell me a little bit about the Go API? What are the motives behind developing the Go API? And some of us on the stream, they're aware that one of the cool features about using Solace PubSub Event Broker is the ability to connect to open standard protocols like MQTT and MQP. And others using Go in their microservices, they could still connect to the Solace Broker using an open standard MQTT messaging protocol, for example. What are the motives behind developing a native Solace API in Go?
Yeah, so basically, there's a couple of main points, probably three in total, I'd say. Number one is always, of course, customer demand. So we've heard it multiple times from the field, specifically the sales engineers who have garnered a lot of feedback from customers, and more customers have asked us to have a native API.
Right.
Now, another very important point is the fact that Go is very much increasing in popularity, and it really aligns with what we do here at Solace, which we like to call some plumbing work. So Go, it very much serves the same kind of area/space where it's used for a lot of microservices, a lot of areas where you need to fill in the blanks and kind of create some standalone functionality to help other applications kind of do what they need to do. And of course, at Solace, we're always kind of striving to make our platform available everywhere. So we really want to be kind of language and platform agnostic. So if you have applications running on any odd, strange area, as a lot of large enterprises do, where it's very fragmented, they have Java applications, they have C# applications, they have old C applications, and a lot of them now are having Go applications. So this is just another area for Solace to kind of give additional offering to our customers and allow them to connect from additional areas. Right.
Yeah, you actually bring up a good point regarding kind of the silos of different applications, or sometimes you have like a polyglot of architecture with using different programming languages. I want to share my screen and show. So if I put it over here, so on solace.dev, we have one diagram here that shows the different APIs and protocols that we can connect to the Solace Broker. So you can see here that the Solace Broker, one of the features is interoperability and protocol translation between different languages and protocols. And Solace has we have our own native APIs, including the Go API. But again, as you mentioned, other enterprises, they could use different programming languages, they could use different messaging protocols that connect to the message broker. And then even if you use the native Go, the native Solace API, the Go API, you could still communicate with other languages up here and protocols.
Yeah, exactly. And to kind of touch back on one of your other questions in terms of why use these Solace native APIs as opposed to, for example, we support MQTT, which is an open protocol, and there is a Go API for MQTT that customers can use currently. And the reason we wanted to have our own native API is really to be able to use all the very rich features that the Solace Broker has. And with the open standards, they're able to do simple PubSub functionality. But if you really want to take full advantage of the Solace Broker, we need that native API to really be able to communicate with the broker and expose the whole feature set to customers. So it's not just a limited range.
Nice. Okay. Perfect. No, thanks for shedding some light on this. As we get people more trickling in into the stream, we have people joining us from the UK. Hey, LinkedIn user from the UK, thanks for joining it in. Andrew McKenzie from Ottawa can confirm that is nicer and sunnier than Vancouver today. Andrew, I don't know what to say. It's usually sunny in Vancouver. So thanks for tuning in. Anybody else who's joining us, let us know where you're joining us from. Murat, I have another question for you regarding the Go API. So since this is a new API, it's the latest API released by Solace, and it's the first open source API that Solace have released. What are the different features that are currently supported in the Go API, and how can people know what are the features that are supported in the Go API?
Yeah, so the very recently released Go API is, as you mentioned, our most recent, and it's also the most feature-rich to date. So we previously released Python, .NET, and others, which were not as feature-rich upon their initial release. But because this is coming out at a time where there's been a lot of maturity in terms of features added to the broker, there was also the demand to have all that functionality, or as much of it as possible, ready upon initial release. So of course, this includes direct messaging, so regular PubSub, subscribing, unsubscribing. It includes persistent messaging, binding to queue, creating durable endpoints, the addition and removal of topic subscriptions, and of course, triggering message replay, which is another very nice Solace broker feature, and selectors. So in addition to that, of course, all the regular broker connectivity support is there for SSL TLS, including compression, and more recently for the authentication portion, we have support for now basic authentication, client cert, more recently OAuth, and of course Kerberos.
Nice. This is indeed a feature. There's like a lot of feature-rich release for sure for this one, for version 1.0.
Exactly. It is very feature-rich. And of course, there's a lot still on the roadmap for items that are coming up in the very near future as well.
Nice. Yeah. Speaking of features, I want to show everyone the Solace community. So if you go to solace.community, we have a section on solace.community for our released notes category. So I'm going to go ahead for the category for the released notes. And then we published a post for the Go API, and there's like a list details on a summary of the supported features and what's coming up next. So this is kind of what you mentioned, what you talked about, Murat, on this.
Yeah, exactly.
Okay.
And as you can see from the kind of roadmap features, there's a couple of things sitting there. We have support for PubSub Plus cache.
Okay.
So this is in order to support PubSub Plus cache, which there is a little bit of work required on the API side. Then, of course, we have the request reply message exchange pattern. And another coveted feature, which has already been asked for while this API was still in EA, was transacted sessions.
Yes, I've been asked a couple of times for transacted sessions on when it's coming. So I'm glad we're talking about this. And if anyone on the stream listening is looking for transacted sessions, stay tuned. It's coming up, as Murat has mentioned.
Exactly. It will be coming up. And very lastly, we have queue browsing. So all of these are on the roadmap, plus some additional ones of very new features that are going to be coming to the broker in the very near future. So there's a lot of excitement and a lot of features that are on the roadmap, and I can't wait for all of them to be available to everybody.
Perfect. Okay, thanks for this overview and rundown of the Go API. Murat, if anybody wants to get more information about the Go API, what's the best place they could go to and ask questions for either the roadmap or questions about the Go API?
So, of course, we always encourage everyone to come over to the Solace community. If you really want that quick response, sharing information, sharing your know-hows with like-minded people, the Solace community is really the #1 place. And myself and a lot of the other Solace employees are very active on it. So We're constantly checking what people are posting. So if you have any questions, suggestions, posting on the community is probably the best way to go.
Perfect. Okay, thanks for this input overview. I think right now we really want to focus on for this live stream. We're going to do some hands-on coding. Let's get into it and see what kind of live coding. How can we use the API? How can we download it and have some fun coding? So before we do that, again, I want to remind anyone, if you want to join the community, go ahead and start us a community. We are currently running a fun activity and a fun event throughout the month of April. It's an Easter egg hunt. Some of the questions for the Easter egg hunt could be, the answers for the questions could be found on the Solace community, on our Twitter account, on our newsletters. But also, I will be releasing today an answer to one of the Easter eggs that have been released. So stay tuned. The answer for one of the questions is coming up. So while we get Michael on the call, I would like to ask anyone here, just let me know, what is your favorite Golang feature? If you're currently using Go, if you're programming Go, what is one feature in the Go programming language that you like that stands out to you? Put it in the chat, whether you're LinkedIn or YouTube or Twitter, just put it in the chat and I will see it, put it on the screen. So without further ado, Murat, thanks for the intros, and I will introduce Michael.
Thank you.
Michael, how's it going? How are you?
Not bad. How are you?
I am doing well. I'm doing well. Where are you joining us from, Michael?
From sunny Ottawa. 17
Ottawa.
and sunny today. We go back to the rain tomorrow, so don't worry about it.
Okay, yeah. So I have Andrew on YouTube saying that I have to come back to Ottawa if I want sunny days there, but I'll stay here for a while. Okay, thanks for coming on the call, Michael. What are we gonna do? What are we gonna do today?
So we're gonna look into a couple of the features of the new Go API. We're gonna focus on a receiver and then get a publisher going, and then maybe dive into something pretty cool at the end.
Okay. Sweet, that's great. One thing I realized that we're all wearing the same shirt. This is we're doing like representing Solace, but I'm trying to be at the same line as Murat. This is great. Today is a Solace swag kind of stream, which is great. All right. Well, I will go ahead and put your screen on the stream. Let me see some of the audience. So one of the favorite Go feature is the low level patterns. Great. I love listening to other people talk about the Go API or different features that they like. It's cool to see what other people use Go for. All right. So Michael, I'm going to go ahead and share your screen and we'll take it from there.
Sounds good.
All right.
So the first thing we got to do is figure out how we're actually going to get the API. So this page, if you're a Go developer, probably looks pretty familiar. This is pkg.go.dev, and it's the home of pretty much every package you could possibly want.
Right.
So let's try to get the Go API. So we know that it's called Solace. So actually, let's just search Solace. And you can see right here, we get solace.dev/go/messaging. So with this, we got a nice getting started with a go get command. So I'm just going to copy that. We're going to use it in a second. And let's create a new project. So
it's great.
Live coding. Let's go in there.
Nice.
Nothing in there right now. So let's start off the project by doing a go mod init, and we'll call this live coding.
And Michael, what version of Go are you currently using?
I'm using 1.17 on Darwin.
Okay, awesome.
So this works well because if we look into here, Solace API requires Go version 1.17 plus.
Nice.
So we should be good to go.
Awesome.
So now I should be able to just paste in that command that we copied, go get Solace dev, go messaging.
And that just gets the Solace Go API and installs it.
Exactly. And it'll grab by default the latest version. Right now we got 1.0.0. And let's open this up in VS Code because I'm not a Vim guy.
Okay, sweet. Let's get to see what we can do for today.
Right, so we can see it's now installed the Go API.
Right.
Let's get going. So I'm going to create a first file called receiver.go. We're going to put this in the main package, which lets us run it as an executable, and we'll create our main function. So for now, print line, hello world. And there we go. It'll import FMT automatically when I save in VS Code. Now I should be able to go run receiver.go. Go run is really just a short form for compiling and then executing the executable. So both steps together, we say hello world.
Okay, great. And now that after we installed the Solace Go API, and I see that the name of the file we have is receiver.go. What are we trying to do today for at least for this file?
So the first thing I think we should try to do is see if we can get something up and running that'll receive messages. What we can use is something called the try me page, which should allow us to connect and publish messages. So that's going to be our goal, is publish a message from this page here, which we can configure to connect to our Solace event broker. And then we want to receive those messages in our application.
Perfect. Before we started the live coding session, I created a public Solace broker, a Solace Cloud broker that we can potentially use. So I'm gonna put the public.messaging.solace.cloud. The public broker is this one. It's public.messaging.solace.cloud, and this is something that we can use to connect for this live demo. So, and I believe it's on port 443.
Perfect.
Yep. And I have the username. It was live coding. Do this, and the password is live coding as well, and the VPN is public.
I think it's live demo.
Live demo. That is correct.
Yeah.
Yes.
So there we go.
Okay.
We tried connecting with the try me, so now we're connected.
Okay.
So we should be good to go there.
Cool.
Let's dive into actually using the API. So the first thing that we get is we have to get a messaging service builder. So everything in the API centers around something we call the messaging service. This allows you to connect to a remote broker and then get whatever services you want out of that. So for example, if you want to have a publisher, you create that through your messaging service. If you want a receiver, you create that through your messaging service. So let's get our messaging service builder first. And this comes from the messaging package and new messaging service builder. That'll create a new builder for us. VS Code automatically imported Solace Dev Go messaging. And now we can get going with some configuration and then a connection.
Okay.
So the first thing we're going to do is messaging service. Or we're going to first configure the messaging service builder. So when I look at all the functions under the messaging service builder, there's a few things for authentication and things like that. The one we want is from configuration provider right now. We can then use the config package, which is another package provided by the API, and get a service property map. This service property map lets us configure some of the properties. So for example, if we want to configure the transport layer property for the host, we can do that. And then as we saw before, we're going to grab this public.messaging.solace.cloud. And we don't want to connect over WebSocket. We're going to connect over TCP instead. And I know off the top of my head that port's 55555. If you're in Solace Cloud, you can go and look at some of the properties, and it should show you full URL.
And just
The
a
next one,
quick reminder,
yeah.
so the diagram that I just showed earlier with Murat, the different programming languages and protocols that we can connect. Right now, we are using SMF, Solace Message Format. So we are connecting to the Solace broker using a native Solace API. This is why we're using TCP and port 5555. On the web browser, the web browser that Michael had opened previously, we're connecting over a WebSocket. This is why the protocol and the port that we're connecting to the broker is different. So this is kind of just a to point it out.
Yeah, perfect. So the next thing we want to get is the VPN name. So as we saw over here, VPN name was called public. So we'll put that in as well. Then the next thing that we want to do is we have to somehow configure the username and password. So we're using live demo, very secure password.
Yes.
No one will ever guess it. And what we want to do is with authentication strategy. So this lets us set the authentication that we're going to use. In this case, we're going to do basic username password. And as we saw, live demo. I typed those correct. Yes.
Yes.
All right. So now our messaging service builder is all configured to go. So we're going to connect again to the broker as per the host, the public VPN with these credentials using basic authentication. So now what we can do is we can actually build our service. So there's two things that this returns. If you've ever seen Go programming, you can have multiple return values. So our messaging service builder.build will give us a messaging service and then an error if one occurred.
Right.
What we want to do is make sure that error didn't occur. So if error doesn't equal nil, we're going to just panic with that error. And this will simply exit out of the program. Everything will just kind of crash.
Right.
It's not the best error handling. You would want some more robust error handling, of course, in your app, but for the purposes of this,
for like a demo purposes. And I want to point out something here that as we're going through, Michael mentioned a couple times, we're building a messaging service, so that we're following a builder pattern in this new generation APIs. One of the big differences between the classic APIs, the legacy classic APIs, I don't want to call them legacy, it's just the classic Solace APIs, and the new generation APIs is in the new generation APIs, whether it's the new Python, Java, and the Go API, we're following a builder pattern approach where we build the different objects that we want with a messaging service, a publisher, receivers is all build objects, as opposed to creating sessions and have a connection factory to the broker. So people coming from the previous classic Solace APIs, this is a bit of a change on how to use the API, but it's pretty straightforward, as Michael is showing right now over here. So go ahead, continue, Michael.
Exactly. All right. So there we go. We've got our messaging service. It's all built, ready to go, but it's not yet connected. So what we want to do is we want to call connect on the messaging service. And I'm going to do a neat little one-liner that helps us handle errors. So we set error to messaging service connect because connect might fail even if build succeeded. And then if the error isn't nil, then we're going to panic on the error again.
Perfect. Great
error handling. And now we should be able to print connected.
Nice.
Then before we exit our app, so we're going to do something else in here. So we're going to receive messages in a minute here, but just to finish off the messaging service code, I'm going to call disconnect.
For best practices,
yeah. Exactly. It's good practice before your application exits. Just call disconnect. Then it's a graceful termination. So any last remaining things can be properly cleaned up. And then if an error occurred, again, we can panic on that error. So, and then I'm just going to print line disconnected. Now if we go back over to our command line, we should be able to go run receiver.go.
You can hear some background music as we code.
Awesome. So there we go. We didn't hit any errors. We connected and then immediately disconnected.
Nice.
So there we go. That's the basic framework of any app that we're going to use. So in anticipation, I'm just going to copy this quickly to our publisher. We'll take a look at that. We'll come back to it in a minute.
Right.
Let's dive a little bit more into the receiver first. So what we want to do now is we want to create a what's called a direct message receiver. So the Solace API provides two kinds of messages that we can send and receive. We can have direct messages, which are for like large streams of data that maybe you, it doesn't have to get to where it's going necessarily. So this would be stuff like sensor data or something like that. And then we also provide guaranteed messages. So these are the super important things that need to go where they're going. So right now we're just going to focus on direct messages. So I'll create the receiver, and this function also provides an error.
Right.
Messaging service dot create direct message receiver builder. So what this will do, we're using the builder pattern again. So this takes our messaging service, which is connected, it creates a framework for the direct message receiver.
Right.
And then when we call build, it actually creates the receiver. Before we call build, though, we actually want to do one more thing, and that's call a function called with subscriptions. I'm just going to get this back. This allows us to set a list of subscriptions that'll be added when the receiver starts.
Right.
Topic subscription of, let's do live Go coding. So there we go. We have our receiver now. Again, we want to check if the error isn't nil and handle it in a super robust way of crashing the application. So there we go. We got the receiver, but we can't actually start receiving messages yet. What we have to do is we have to set a receive async callback. So using VS Code's nice code completion, it can just magically create the function for us. What this in essence is doing is it's a inline function here. This could be any kind of function throughout your program. So if you wanted to create a message handler up here, for example, we can do that instead. I'm just going to use the inline function for simplicity. So everything's nice in the same place.
Michael, what exactly is a callback function? So now you mentioned, you're adding a receive async that takes in a callback function, or it is a callback function. So what is it exactly in the context of what you're doing?
So what this callback function is actually going to do is anytime the receiver gets a message on the topic subscription live Go coding, it's going to go, hey, I know what to do with this. They said they want the message passed to this function.
Sweet.
So every single message that comes in will be passed to this inline function here that we pass to receive async. So in this case, we're just going to do the simple print line of the message. So this will just print out the message directly to the console, and that's about it. So we're almost ready to go here. There's one last thing that we want to do, and it's to do with the receiver here. After we build it, it's not quite ready to receive messages yet. We still have to call receiver.start. So each individual component, so for example, a receiver or a publisher, has its own state separated from the rest of the messaging service.
Right.
So this allows you to have more control over when the receiver is actually running. So in this case, we've created it. Then we configure everything needed. So we set the function callback. And only after that, we call start in this case.
And again, similar to what we did before, we'll panic if there's an error in here. Nice.
Exactly, yeah.
Okay.
We'll crash the application, the best error handling you can ever ask for. Then what we're going to do we're just going to give it a 60-second sleep.
Yep.
This will mean that the app just sits there. It'll receive whatever messages it can for 60 seconds, and then it'll
Right.
terminate.
Right.
And
production ready.
Exactly. Yeah. This is how all my microservices work.
Nice.
The last thing we want to do is call receiver.terminate before we
Okay.
call a messaging service disconnect. This will let us finish processing all the messages that might be sitting in the receiver waiting to be delivered.
Mm-hmm.
And it lets us gracefully terminate.
Nice. Okay.
All right. And then I'm just going to add one more print line here. Receiving messages. So this should be pretty much good to go. So if we walk through the code once more, we create our messaging service, configure it to connect to our public messaging Solace Cloud. We then connect the messaging service. We create a receiver through the builder,
Right.
add a subscription, and call build. Then from there, we're going to set what happens when we receive a message, and we'll start the receiver. Then we just wait a little bit and terminate everything gracefully. So this should be good to go. Let's try running it.
Let's give it a shot.
So one more thing, I'm just going to make sure that my publisher is still connected over here. So go run receiver. My topic was live Go coding. So I'll publish a message on that. And we'll say hello world. Why not? So there we go.
Nice.
We can see we received hello world on live Go coding. So this is good. Nothing's gone wrong yet. We're in good shape.
Okay, great. This is fantastic. We're able to have a receiver. It's running and connected to the broker, and we're able to test it. I know previously you mentioned that in anticipation, you copied the file for a publisher. So now here, yes, you ran a receiver locally, which it's going well, and thanks for that. And again, if anybody has any questions, feel free to put it in the chat window. We're coming to a very cool demo as well soon, so stay tuned. Yeah, so that's Michael, back to you.
Perfect. So now that we got a receiver going, let's get a publisher going as well. So again, I have this boilerplate code here of the messaging service. It connects, everything like that. And now we're going to change this to publish messages. So what we're going to do is pretty much the exact same thing, but instead replace all the words receiver with publisher. So publisher error is equal to messaging service dot create direct message publisher builder. And we'll call build on this.
This is message receiver. You want the message publisher.
Oh, did I actually click enter on the wrong one?
Yes.
That would have been weird. That wouldn't have worked very well. So there we go. We got the publisher all set up. Again, we're going to start it.
Nice.
Error doesn't equal nil. Panic error. And if error equals publisher.terminate. We'll put a grace period again of 10 seconds. So that gives 10 seconds for any remaining messages that might be buffered to make it out, for example. So there we go. We got to start and terminate. We're all set up. Let's
say we could publish in a loop or something, perhaps.
Sure, that sounds good to me.
Yeah.
So we'll use for loop, I is equal to 0, I less than 10, I plus plus. And I'm actually going to do one change to the receiver quickly. And I'm going to add this little section at the end, which means any topic string starting with this will be received. So this allows us to actually publish on a couple different topics that might contain some additional information.
Right. One thing I want to mention here as well, like it's a feature of Solace, when an advantage of using Solace. Topics are not pre-created on the Solace broker. The nice thing about the use of topics in with Solace is they're dynamically created, and once a publisher publishes a message on a particular topic, this topic was dynamically created on the broker. So this gives us the ability to create dynamic topics when publishing. Do you think, Michael, we could at least show how we can publish to dynamic topics, at least, like even have every time I publish a message, it would be a different topic for the publisher?
Yeah, so we can do exactly that. So in this case, we're just going to have it start with this, and then let's have our publisher be smart about it. And the topic string is going to be sprintf. I can type. And what did we start with? Go live coding? Live go coding.
Yeah.
Live go coding. And then we'll have it just use the number. Nice. So each time this is going to be live go coding 0, then live go coding 1, so on and so forth. And this could contain additional information too, like tests.
Yeah, because you added that wildcard in the topic subscription as well.
Exactly.
Right.
So now we can get a message going as well. So again, using the messaging service, which is the center point for everything, dot message builder. So this lets us build messages, and we can configure all these different properties on it if we wanted to. We're going to ignore all that right now and just build with string payload.
Right.
In this case, go back here, put that on a new line. We'll print out a string, hello, whatever number.
Okay.
Again, robust error handling.
Nice.
And now we can use our publisher.
Right.
And call publish. So this accepts a couple arguments. One's the message itself, so let's use that. And then a destination as a resource topic. So we can use this function topic of with our topic string, and that'll create a topic for us. Nice.
And every time you're creating a different, you're using a different part of the library, it is being imported automatically as well at the top. So you see now we have the messaging, the config, the resources. Every time everything you use is being imported, and that's kind of magic and kind of with the help of VS Code Go plugins as well. But that's also to point out that everything that you're using is being imported.
Exactly, yeah. So that resource package that we just used here, when I saved, it automatically got imported. If you're using another text editor that maybe didn't have this, you would have to manually add this line.
Nice.
Up in the import.
Okay, so now we have a publisher running. Just want to remind anyone who's on the channel, who's watching us live, let me know what's your favorite Golang feature, as well as we're coding, and we will be listening to your comments. All right, Michael, back to you.
Perfect. So let's try running this. So we're going to actually need a second terminal window here. Oh, that's small. There we go. Go into live coding. So we have our publisher and our receiver. So let's first start by running our receiver. So this should say connected, and it's receiving messages. Now we can run our publisher. It said connected, publishing, disconnected. And then over here on the receiver side, we see we got all these different messages, each one with a different dynamic topic. So coding 0, 1, 2, so on and so forth. And we can see they all got received. And this will just wait for that 60 seconds before it terminates. I'm just going to kill it now.
Yeah. No, this is great. Like, we were able to run a publisher and a subscriber as well directly from terminal. I want to point out something as well. Comparison between the classic Solace APIs and the new gen APIs. So you see in the publisher some of the things that people might have been used to using is message reset. So if they're building a message, for example, and they want to reset the message text without building a new message, this concept could also be done where we build a message builder basically outside the for loop. And every time we're in the for loop, we can configure things in the message. So you'd see here, we just created a message builder, but the actual content of the message could be modified within every time we do the loop. So this is, a nice thing to keep in mind when, if you want to do a message reset, for example, you can modify the message builder, the content of the message builder in there. So Michael, we have a receiver and a publisher running, which is great. Before we move on to the next part of the live coding demo, do you have anything else to add?
No, I think that covers most of the things that we want to look at in here.
Nice. How's your experience so far with coding this live? You're doing great.
This is good. Yeah.
Okay. Great. So let's say, Michael, if you want to, do things a bit more closer to real world use cases. All right. Let's say there is I want to connect to a stream of data that is being published using the Go API, as opposed to having just the for loop of publisher. I want to connect to real data. There is a there's an endpoint for taxi data that we put together that you can connect to, and with this endpoint, you can receive a stream of taxi data. So if you open a new browser and go to marketplace.solace.dev, which I believe you already have it up.
Yep, we don't already have this up. This wasn't pre-planned.
Fantastic. So if you go at the top, so it shows in here that you can connect to this public broker. It's a server that you can connect to, and the host name of the server is taxi.messaging.solace.cloud. And basically, it's a data set that came originally from New York City taxi data, pretty much. So I don't want to give too much about this data. Let's assume that you don't know how the data looks like. So this is kind of documentation on how to connect to the servers and what are the topics that you can connect to. So even if you scroll down at the bottom, so let's say if you connected to this server and you subscribed to these topics, you can receive a payload that is dependent on this. So on the right hand side, this is the payload that you should expect to receive if you subscribe to this topic. If you connect to this broker and subscribe to the right topic, you should be receiving this. So let's go ahead and try to connect to this broker, subscribe to a wildcard topic, and see just visually from the subscriber what is the payload that we'll be receiving, and how we can create a use case for this using a Go, like fully doing a Go microservice. Let's say today, Michael, I came up to you and I hired you for my New York City company, and I'm like, Michael, you're hired, and we want to create some sort of like dashboarding, real-time dashboarding. And hey, by the way, all we use is Go. This is the only thing that we use. So what can we do with this?
Sounds good. Well, let's first take a look at what the data actually, like what data we can receive.
Okay.
So let's go ahead and connect to this. So I'm going to copy the TCP SMF URL here.
Nice.
Move over from here. So we're going to go back to our receiver and change the host. There's a little bit more information we got to edit as well. So the message VPN, NYC modern taxi. So we'll replace public with that. Public taxi user. So put that in, and I like taxis.
Nice.
That seems good. All right. So the other thing that I think we got to change is the topic subscription here. So let's take a look at what the top level was. So we get taxi NYC, ops, ride, updated V1. So let's just take that part, the hard-coded part, and use the wildcard again.
Okay.
So this means that we'll receive everything regardless of whatever these parameters happen to be. So that should be good. The last thing I think I want to do is, instead of dumping the whole message, which isn't particularly clear, We want to get the payload as inbound message.get payload as string.
Nice.
So we're just gonna check if the error is, check if we can get the payload as a string. So each one of these, it returns a Boolean indicating if there is actually a string payload for us to get.
Right.
So now we should be able to print out that payload.
Okay.
So that should be good. We changed the connection parameters, changed the topic, and printing it out as a string. Let's try running it. So it should, yeah, that's a lot of data.
Look at that. Okay, we have a lot of data coming in right now, and it was pretty fast. And this is live data that is coming in. So I think we can do like a lot of cool things with this. Let's inspect the payload. Like what is it? What is it that we're getting?
Right. So looking through here, we get some cool information about the location of the taxi, direction it's going, speed. We get some information about the driver and the passenger, as well as the ride status, meter increment, things like that.
And like every message that is received, it's pretty much like a different event that comes in.
Yeah. So if we compare this one, for example, to the previous one, we can see they're both en route, but this one has a different ride ID. And the passenger ID is different. We get Larry Sager instead of Dennis Schmidt.
Right.
Or that's the driver, but
okay, yeah. But we get like different payloads.
Yes, we get different information through the whole thing. They're at different locations, slightly. It's all in New York, I guess. So pretty close together.
I think what would be cool, like, you know, so now we have this data. If we wanted to kind of like visualize it somehow, at least show some sort of like visual representation of the data, and you know, like have an example of event-driven data analytics or event-driven data visualization. I know Go has a plethora of different libraries and packages that we could use for anything pretty much we want. And some of the things, there's a lot of like charting libraries. Do you know of any good charting libraries for this?
Yeah, definitely. So there's this charting library that I found called eCharts, Go eCharts. What it is it's a Go wrapper for Apache eCharts, which is a library that pretty much lets you create a ton of different charts. So if I start looking through a couple of the ones that they give here, trying to get some inspiration, we see this one here, which looks like a little speedometer, right? So that's something that is real time that could very well be important to see, is what's maybe the average speed of all the current drivers, something along the lines of that. So then that can update over time and we can see exactly what's happening.
Right.
So let's dive into that a little bit.
Give it a shot. Yeah.
Yeah. So the first thing we're going to have to do is actually install the eChart library. So going back to the top here, I'm just going to copy the URL. They have a Go mod example here, a Go get, a bunch of stuff like that. Let's go get Go eCharts. So there we go. It's added, as easy as that. And yeah, we're going to have to change some of this around a little bit because we want to get the average speed out, right? So let's work on that part first, and then we can work on the actual display.
Okay.
So I'm going to do a little bit of refactoring here. I'm going to change this receive async function into a function up here, receive message. So now we can pass in receive message as a parameter to receive async.
Nice. Okay.
So all this is doing, instead of the closure, we get it up here. So that's good. Now, one other thing that we want to do is we aren't actually interested in getting all this data. We just want a couple pieces of the data. So one thing might be the ride ID.
Yeah.
And one thing might be the speed. So let's get some of those out. I'm going to use something that's a really cool feature, one of my favorite features of Go, which allows us to unmarshal JSON directly into a structure. So ride info, and it's going to be a struct. So I'm creating a new struct to hold our information. The couple of pieces that we needed, one was ride ID, one was speed. So ride ID, and this looks like a string to me. So do a string, and then speed, which I'll set as a float 64.
Nice.
What we can then do is we can take this payload and use the built-in JSON package and call unmarshal. We're gonna create info, ride info. We're gonna pass the payload. I think we have to do the payload as a byte array, so we'll just do a little cast here. And we'll pass info. So this now should take in the payload, unmarshal it to ride info for the things we care about. And now we should be able to print out the ride info.
And this is one of my favorite as well Go features, is the unmarshaling into a struct, which is like a pretty cool, neat way to like take a JSON body and like map it into a particular predefined struct.
Exactly, yeah. So let's try running this. And we should just see printouts of ride IDs and speed.
Nice.
So that looks like what we're getting.
Nice.
So that's good. From there, we can move on to trying to figure out a way to average all the speeds. So I'm going to create a new global variable because, again, production ready code, right?
Yes.
So just to hold our average speed. And then because we have a lot of different rides and the speeds are updating all the time, if we want to get a real-time picture of that, we need to only store the latest speeds of each individual ride that we get. So the best way to store individual things, in my opinion, is a map. So speed map. And this is just going to be a map of strings, which are the ride IDs, and the speeds, which are float 64s. And I'm going to just initialize the map here. And then float 64. So there we go. We created our speed map. We make sure that it's not nil, which is always a good thing to do.
Yes.
And now let's store speed map at info.rideID and set it equal to info.speed. So now we should be able to store all of the different speeds in a map. And now let's just write a quick algorithm to average them out. So var total speed equals 0 for, we don't care about the ride ID. Speed is equal to the range of the speed map. And total speed plus equals speed. And then average speed. I think I have to set this to float 64. There we go.
Right. And then just get the length of the speed map. Okay.
Exactly. So that should give us the average speed now. Yeah.
Nice.
Let's just print this out for now. Average speed. So we can test our code, make sure it works. And we can see it's just spitting out numbers between 12 and 13 by the looks of it. Over time. And that looks about right. We see like 8, 18, 32, 22, 16, 2. Some of them are stopped. Like this one's stopped down here.
Yeah. So it's just like averaging the speed.
Yep. So that looks good to us here. So now we can jump into some of the graph stuff. So just for simplicity, because we aren't focusing that much on the graphing library, I'm just going to copy in a little bit of code that we got going. So there's a couple functions here that I'll paste in. One of them's gets the graph.
Yep.
So it creates the gauge and sets a bunch of options and everything like that. It gets the average speed and it rounds it to a couple decimal places just for display. And then we're going to render it with this handler onto a web page. To do that, we can use the built-in HTTP server. So instead of sleeping now, we can put this in.
Okay.
And I'm actually going to grab all of this stuff, all the cleanup code, and stick it in my other favorite part of Go, which is defers.
Yes.
So what this lets us do is it just says when this function's returning. So if you control C out, for example, run all this stuff. So terminate to the receiver, then disconnect the messaging service.
And everything in this function will be executed after the main function returns, pretty much. Hence the defer.
Exactly.
Yeah.
So once this returns here, then it'll go to this defer.
Nice.
So there we go. That should be everything we need. So we got our gauge set up, we got the averaging set up, and we're hosting a web server on localhost 8080.
Nice.
So let's try this out now. Go run receiver.go. And actually, just to show it off, let's build receiver.go.
Yeah.
We're pretty much done. So awesome graph. Oh. There we go. Awesome graph. So this will create a single executable now, one of the other powers of Go, that we should be able to take to any other macOS system, in this case, and just run it. So now we get awesome graph.
Nice. And this one, like you could run this. Oh yeah, we had the
yeah, let's get rid of that.
Yes, okay. To the build. And pretty much just executable. Now you could run it on any macOS system again. And what it does is what's in the code, pretty much.
Exactly.
Yeah.
So now let's go to localhost 8080 and we can see the speed.
Nice. Okay, this is very neat. Right now, we're able to create a microservice, basically, pretty much. So what you were hired for, Michael, you delivered pretty much, is having a stream of real-time taxi data coming in and create a real-time dashboard speedometer, basically that shows the speed. This is very cool because we were able to show how we are connecting to a Solace broker using the new Solace PubSub Messaging API for Go, modify or handle the data that is coming in, pretty much, and make a use case. We have a use case out of this, which is pretty neat.
Exactly.
Yeah.
And you can see how this could be expanded to something a little more meaningful than just showing the average speed on a web page. You could take it in and imagine if you had a loyalty program that maybe if the delta between when a ride was accepted and when the passenger was actually picked up, if that was a long time, maybe you want to send them a promo code or something like that. You could have your microservice receiving these events, checking the times between the start and the ride accept and the ride pickup. And then if that's too big, goes and sends another event off to your loyalty program microservice, which says, hey, I got an event to go and send out a promo.
Right. And this is a pure event-driven architecture. I know Murat is on the call. Bring him in and see what he thinks about this use case. Murat, what do you think of this use case? So it's kind of like we're able to use the Solace PubSub event messaging API for Go and create some sort of operational use case for a stream of data that's coming in.
I think it's fantastic. I think it showcases all the basic features that you need and plus some to kind of give an example of what you can do with EDA. So it's fantastic. And I was actually following along, trying to replicate what Michael was doing. So fantastic work.
Thumbs up. Yes. Okay, fantastic. I think we're coming close to an end for this, which is great. This was a very interactive session. We talked about the Go API, the motives behind the Go API. Murat gave us a quick overview about what are the different features and the roadmap, where to get more information about the Go API and the different kind of initiatives that we're still working on the Go API and the new features that are coming up. Then we delved into demoing and showcasing the Go API with Michael, and downloading the Go API, we're able to demonstrate a basic publisher and receiver using the new builder pattern. One thing I wanted to mention as well, that you can also check out the documentation on Solace Docs. If you go to Solace documentation, you could see the Go API documentation and read everything about the API. And lastly, we showcased a use case, a real-world use case using the Go API, and how an operational use case of an event-driven architecture could be done using the Go API. So we're gonna wrap it up over here. Michael, Murat, do you have any further things you wanted to say before we call it a day?
No, just thank you for everybody that joined. And like Tamimi mentioned, if you have any comments, questions, come over to the community, check out the docs. We have a lot of information. So if you want to dwell a little bit deeper than Michael's quick coding, there's a lot of resources for it.
Right, and there's we already have samples using the Go API on the Solace samples GitHub repo, so you can go there, check out the Go API samples repo, and there's a bunch of samples that we are definitely more than happy to have you all check out. So that's about it. We're gonna call it a day. Thank you again, gentlemen, for joining, and thank you everybody who joined us on the call. And stay tuned for the next event that we have. Murat, Michael, thank you very much for this. Really appreciate your participating in this event for today.
Thank you very much.
Thank you. This was fun.
Thank you.